So hello everyone, this is Professor M.S. Navakar, faculty from Chemistry Department, Hirashugan Institute of Technology and Research. So in previous lecture of solar energy, we come to know the introduction part of photovoltaic cells, advantages and disadvantages of photovoltaic cells, and utilization of solar energy by direct method and indirect method, and also we come to know the importance of solar cells. In this video lecture number 2, let us begin. The very important part of this chapter is the construction and working of photovoltaic cell. As you know that the photo is nothing but in Greek language the light, and the word volt, which is the name of a pioneer in the study of electricity, who is known as Alexandro Volta. And for the photovoltaic cell technology, in the year 1921, Albert Einstein was awarded Nobel Prize in Physics, so based on the principle of the photovoltaic effect, which is the phenomenon that is taking place, the generation of electricity in the photovoltaic cells, or you can say the solar cells. As already we have defined, the definition of photovoltaic cells means what? The photovoltaic cells are the semiconductor device, so which converts the solar energy into electrical energy. That's what we come to know in the first lecture. Or also, we can define photovoltaic cell are the p-n junction diodes, so which converts the solar energy into the electrical energy. So this conversion of solar energy into electrical energy based on some important principles which are exhibiting in the semiconducting materials which are used to make the photovoltaic cells. So let us begin. The first one, photo generation of charge carriers in light absorbing materials as a result of absorption of light radiation. The second is what? The solar cells are based on the principles of photovoltaic effect. What I explained, the photovoltaic effect is nothing but the creation of voltage and electric current in a material. When it is allowed to expose to the light, it is the property of physical and chemical phenomenon of the material which is used for the energy conversion from light energy into the electrical energy. The third principle, what it explains, the separation of positive and negative charges carriers by the potential gradient within the material. That is what? These are the three important principles which are leading to the energy conversion of solar energy into electrical energy by the photovoltaic cells. In order to explain the construction of the photovoltaic cell, let us begin the brief information about the diagram of photovoltaic unit. That is what I am explaining in this slide. What can observe here in this photovoltaic cell construction, we are going to use the semiconducting materials like we can use arsenide, indium, cadmium, silicon, selenium, gallium are some important metals are used to make the semiconducting materials. But usually we are using silicon and selenium are the semiconducting materials for making the photovoltaic cells. In this photovoltaic cell unit, what you can observe that we are using the silicon as the semiconducting material for making the photovoltaic cell, we can observe that the upper surface of this cell, what I can show here, it is made up of N type of silicon, which is doped by the phosphorus, which is having the dimension of 2 to 3 micrometer. Okay, and this is placed over the P type of silicon, where it is doped by the boron, which has the dimension of 250 to 300 micrometer thickness of the two slices. Here, N type of silicon slice is placed over the P type of silicon. Both are sandwiched at the interface. There is a formation of what can observe. There is a p-n junction diode. So here the silicon what you are using most probably is what a monocrystalline silicon are used to make the semiconductor and photovoltaic cell. Monocrystalline silicon means the silicon material atoms what we are using in the semiconductor, they are what oriented or what they are directed in the single direction. So this monocrystalline silicon what you are using in this construction of the photovoltaic cell, and you can observe one more important thing. At the front side there are metal grids are attached by leaving some gaps. So the purpose of leaving the gaps is what? Here, when the sunlight falls over the semiconducting material, it should penetrate very more intense into the body of the PV cell unit. And these metal grid electrodes are made up of the titanium silver alloy, and also they act as the negative electrode, or you can say them as emitters. And similarly, at the bottom of this PV cell unit, what you can observe that we have also having a very thin layer of titanium silver alloy, which is made, attached at the bottom side. So this is also acting as the positive electrode. And both negative electrode and positive electrodes are connected to the light source, so where you can get the light energy from the solar PV cell device. So what you can see in this picture, as I told you, there are two semiconducting metals, N type of semiconductor silicon and P type of semiconductor silicon, and where you know that we have attached that electrode grids, so by leaving some gaps where the sunlight enter into the body of the PV cell. And here, in between the metal grid electrodes, there is an anti-reflecting coating which is made by the use of the compound. You can take the silicon nitride, or you can take the titanium dioxide compound, anyone. And this is what generally I have explained about the brief information of this PV cell unit. So if this parameter of the dimensions have been used for making the photovoltaic cell, there is the generation of electric power around 0.5 to 0.6 volts. So that's what about the brief information what I explained by looking at the diagrams of the photovoltaic cells. Now let us discuss in detail about that construction. The solar cell, as I told you, is what the monocrystalline silicon, which is what made up of consisting of N type of semiconductor, which is called as an emitter, having the very thin slice of 2 to 3 micrometer layer, and which is placed over the base material of a P type of semiconductor silicon. So that is acting as an acceptor, so whose diameter is what around the 250 to 300 micrometer thickness. So when both different type of silicon metals are placed together by they have been sandwiched with thin slice, hence there is a formation of the p-n junction diode at the interface of the two metals which are in contact. As I explained in the diagram construction explanation, the metal grid electrodes are what? They have been attached at the front side, made up of the titanium silver alloy, are attached on the front side to allow the very intense light radiation into the PV cell unit, and it will act as a negative electrode, and the metallic layer of a 0.2 micrometer titanium silver alloy is also attached at the back side of the PV cell unit, so which will act as the positive electrode. And as I explained, the surface is coated with the anti-reflection coating made up of silicon nitride or titanium dioxide to avoid the loss of incident light radiation into the body of PV cell by avoiding the reflection before to enter into the PV cell unit. And this coating is made up of the technique what we can explain that plasma enhanced chemical vapor deposition technique are used to deposit the coating over that in between the metal grade networks. Now let us begin about the working of the photovoltaic cell, how this photovoltaic cell is able to generate the electric power. Let us discuss about in detail. As you know that when the light is incident on the semiconducting material, maybe pass into the body of the PV cell or may be reflected back before to enter into the PV cell body. And this PV cell is made up of what? The semiconducting material. As I explained, we are using here the silicon. And you know that the semiconductors are the materials which have the conductivity neither conductor and or insulator. And this property of semiconductor makes for efficient for converting the light energy into electrical energy. When the semiconducting materials absorb the light radiations, so electrons are what? They start emitting. This is because of what? The light consists the small energy of the particles, what you can say the photons. So when the electrons absorbs the photons, so what happens? They get energized and they are moving into the materials. As a result, what you can say that absorption of light radiations, electrons are liberated, and there is the production of the electric power. That is what which you are able to get it from the external circuit. When you know that the photovoltaic energy conversion is what depends upon the number of photons which are striking on the surface of the photovoltaic cell. As you know that if the day was clear, it is observed that 4.4 into 10⁻17 photons can strike on square centimeter of the PV cell unit, so every second. But only those photons which are having the excess of energy than the band gap energy, they can jump the electrons from valence band to the conduction band, so they are able to convert the solar energy into the electrical energy. When such a photon enters into the semiconducting material, that may be absorbed, that is promoting the electron from valence band to the conduction band, so thereby what happens? Creation of holes in the P type of semiconductor and excess of electrons in the N type of semiconductor. So they are going to migrate in the opposite direction, leading to form the electric power generation. So here, energy of the photon, how we can calculate? That is what given by the equation E is equal to h nu, where nu is nothing but what? C by lambda, and as you very well know, h is the Planck's constant and c is the velocity of light and lambda is the intensity of the light which is striking over the photovoltaic cell. And the electrons are made to move across the external circuit, and thus what happens? The photoelectric current is produced which is available for our use. As I explained, this typical PV cell can produce around 0.5 to 0.6 volt of DC power. This current output depends upon the efficiency of the efficiency of the material what you are using, and the size of the PV cell and the intensity of the sunlight which is striking on the surface.